Pluto is a far-off and subtle, more straightforward planet that was once a part of our nearby planetary system. However, recent unsettling declarations by leading astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight. They suggested that this frigid world is on a potential crash course with Neptune. But how could this actually happen, and what might be the consequences of such a massive event? Are we witnessing a perplexing cosmic anomaly? Or is there more to this looming celestial disaster? Join us as we explore the possible outcomes of a Pluto-Neptune collision. Pluto, a former planet that was reclassified as a dwarf planet, remains a subject of interest and study in the vast universe. According to recent estimates from leading experts, Pluto's orbit is dangerously close to Neptune's. Astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising alarms about a potential catastrophic collision between these two celestial bodies, which could pose a significant threat to Earth. But how is such an event even possible? Pluto's journey around the Sun is unlike that of any other planet in our solar system. It takes a staggering 248 years to complete a single orbit, and since its discovery in 1930, it has not yet completed one full revolution. However, the intrigue doesn't stop there. Pluto's orbit is characterized by its highly elliptical shape, deviating significantly from the nearly circular orbits of the major planets. What makes Pluto's orbit even more remarkable is its inclination, tilted at 17 degrees to the ecliptic plane. The way Pluto follows its path is far more irregular compared to the other planets. This inclination and eccentricity add layers of complexity to its orbital arrangement. Perhaps one of the most fascinating aspects of Pluto's orbit is its intersection with Neptune's. For approximately 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune, defying what we would typically expect from their positions in the solar system. This raises an obvious question. Why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other planets. The study of Pluto's orbit began shortly after its discovery. Initially, astronomers sought to understand its unusual trajectory. Unlike other planets, whose orbits lie relatively close to the ecliptic plane, Pluto stands out due to its deep inclination and unpredictable shape. The mystery deepened when astronomers realized that Pluto's orbit does, in fact, cross Neptune's. The stability of Pluto's orbit, despite these complexities, is a testament to the intricacies of celestial mechanics. The three-body problem in space involves predicting how three objects, such as Pluto, Neptune, and the Sun, move and interact with each other through gravity. It's akin to predicting their future positions based on their starting points and gravitational influences on one another. In Pluto's case, this problem demonstrates how its orbit, Neptune's orbit, and the Sun's gravity all work together in a delicate balance. Several key concepts help explain this stability. 1. Mean motion resonance. In Pluto and Neptune's case, this means that when Pluto crosses Neptune's orbit, it is positioned roughly 90 degrees away from Neptune. This spatial separation is crucial in preventing their orbits from intersecting at the same time. 2. Orbital precession. This refers to the slow, cyclical change in the orientation of a celestial body's orbit. For Pluto, this means that when it gets closest to Neptune or another giant planet, it is positioned far above their orbital plane, adding another layer of protection from potential impacts. 3. VZK wobbling. Named after three scientists, Vladimir V. Vasilyev, Alexander Zeldovic, and Michio Kaku, this phenomenon describes how three celestial bodies, like Pluto, Neptune, and the Sun, exert gravitational forces on one another, influencing their movements. Despite Pluto's orbit appearing chaotic, this wobbling effect helps maintain its stability over long periods. Despite these stabilizing factors, simulations in the late 1980s revealed that Pluto's orbit is highly sensitive to initial conditions. Even minor variations can lead to significant changes over centuries. However, these same characteristics have been found to maintain long-term stability. Studies of planetary disturbances have helped astronomers understand how giant planets, such as Neptune, Jupiter, and Saturn, affect Pluto's orbit around the Sun. Neptune has a special relationship with Pluto. For every 2 orbits Pluto completes, Neptune completes 3. This resonance helps keep Pluto's orbit stable. However, Neptune isn't acting alone. Jupiter's immense gravity also plays a crucial role in stabilizing Pluto's orbit, and even Saturn contributes. Research indicates that Jupiter's gravitational influence is strong enough to keep Pluto on a steady path for potentially millions of years. In a way, Neptune, Jupiter, and Saturn appear to be working together to ensure Pluto continues its journey safely through space without encountering trouble. These gravitational interactions are essential in maintaining the delicate balance of our solar system. Without these stabilizing forces, the solar system as we know it would be a far more chaotic place. Celestial bodies like Pluto could collide with others or be ejected from their orbits, triggering a chain reaction with other planetary bodies. For Pluto, especially with speculation about a future collision with Neptune, understanding its orbit is crucial. This provides a clearer picture of the dynamic nature of our solar system. Pluto's case demonstrates that even seemingly unstable orbits can reach a state of equilibrium through gravitational interactions. The complex cooperation of gravitational forces and orbital mechanics also highlights the significance of consistent observation and investigation of these phenomena to better understand our place in the universe. Exploring the depths of space often leads us to confront the strange nature of celestial bodies, and Pluto's orbit is a perfect example of this anomaly. The concept of orbital chaos, which refers to the delicate dependence of a celestial body's orbit on its initial conditions, is clearly demonstrated in Pluto's case. This means that even slight changes in the dwarf planet's position or speed can drastically alter its long-term orbit. Using automated simulations has been immensely helpful for scientists in understanding how Pluto moves in space. These simulations use complex mathematics to model how Pluto and other space objects like Neptune pull on each other. By tweaking small details in the simulations, space experts can see how even tiny changes can have a huge impact on where Pluto ends up. In the late 1980s, these simulations revealed something fascinating about Pluto's orbit. Despite having features like non-synchronous libration and orbital precession to keep it stable, its orbit can still be inconsistent and unusual. If you start with just a small difference in Pluto's position or speed, its orbit could look completely different after only a few years. Yet, despite this chaos, Pluto's orbit remains stable over vast timescales, billions of years. This suggests that Pluto's journey around the Sun follows a kind of order, even though it appears unpredictable at first. Predicting celestial movements, especially when they involve irregular orbits like Pluto's, is a massive challenge. The inherent unpredictability of these systems means that long-term forecasts often come with uncertainties. While mathematical models provide excellent tools for understanding and predicting the future movements of celestial bodies, they also highlight the limitations of our predictive abilities. These models rely heavily on the accuracy of initial conditions, and any small error or distortion can lead to vastly different outcomes, making precise predictions an overwhelming task. Beyond the chaotic nature of planetary orbits, Pluto reminds us of the ever-changing and dynamic nature of the universe. While we've made enormous strides in understanding space, Pluto's case reminds us how much of our knowledge remains limited. Grasping the gravitational effects of the giant planets on Pluto's orbit provides valuable insights into the broader dynamics of the solar system. It shows that the presence and position of each planet can significantly impact the stability and trajectory of other bodies within the system. So why are leading astrophysicists recently raising concerns about a possible collision between Pluto and Neptune, despite the complex forces working to prevent such an event? Neil deGrasse Tyson, a prominent astrophysicist and a key figure in advancing cosmology, offers a unique perspective on the mysteries of our solar system, especially the intriguing case of Pluto. Tyson, known for his role in reclassifying Pluto from a planet to a dwarf planet, provides insightful analysis on the evolving nature of celestial mechanics and the public's interest in the overlooked corners of space. His stance on Pluto's reclassification is based on the ever-expanding knowledge of our solar system. He sees the reclassification not as a diminishment, but as a necessary adjustment to our growing understanding of the diverse bodies orbiting our Sun. Tyson's approach to celestial mechanics is one of continuous learning and adaptation. He views the complexities of orbits like Pluto's as a sign of how much there is still to discover in space. The fascination with these questions keeps space exploration exciting. However, despite Tyson's optimism, his thoughts on Pluto's potential collision with Neptune paint a different picture. His concerns about Pluto's orbital instability rest on a simple truth. As the solar system continues to evolve, the gravitational interactions between bodies like Pluto and Neptune can subtly shift over time. While the probability of an immediate collision is very low, Tyson and others in the field caution that it could happen over billions of years. Should the gravitational forces between Pluto and Neptune ever become unpredictable or unstable due to minor shifts, the entire system could spiral into chaos. Tyson, along with other astrophysicists, acknowledges that while Pluto and Neptune's current orbital dynamics appear stable, we must consider the long-term implications of their orbits over billions of years. Even the smallest changes in gravitational forces could disrupt the delicate balance that prevents them from colliding. This serves as a stark reminder of the unpredictable nature of space and the vast timescales involved. Although the likelihood of such a collision is extremely rare, it remains a theoretical concern that underscores the fragility of celestial mechanics within our solar system. Neil deGrasse Tyson's remarks also bring into focus the broader issue of how the solar system is constantly evolving. With every orbit and gravitational interaction, subtle changes accumulate. In Pluto and Neptune's case, while their current orbits are synchronized in a way that prevents direct collisions, there is always the possibility that, over immense timescales, this delicate balance could shift. The fact that Pluto's orbit intersects Neptune's for part of each cycle adds an element of vulnerability, one that, while highly stable now, could be susceptible to change under the right conditions. Additionally, there is an ongoing gravitational tug-of-war at play, not just between Pluto and Neptune, but also involving other massive planets like Jupiter and Saturn. These gas giants exert their gravitational influence on Pluto, and while this effect stabilizes its orbit, it also means that Pluto's trajectory is in constant motion. Even small adjustments to the orbits of these giant planets could, over millions or billions of years, shift the gravitational forces enough to push Pluto's orbit into an unstable position. In this sense, Pluto's orbit can be seen as a dynamic, ever-changing puzzle, where all the pieces must fit perfectly for the dwarf planet to avoid potential catastrophe. Yet, despite the potential for change, it's important to remember that our understanding of the solar system is still evolving. As technology advances, new models and simulations provide deeper insights into the long-term stability of planetary orbits. Future observations could reveal even more about how planets interact over time, further refining our predictions and possibly even offering new solutions to these cosmic mysteries. The case of Pluto and Neptune serves as a valuable reminder that, while space may seem vast and unchanging, it is, in reality, a place of constant motion, transformation, and unexpected possibilities. In conclusion, while the idea of Pluto colliding with Neptune may seem far-fetched and unlikely in the short term, studying their orbits offers a fascinating glimpse into the dynamic nature of our solar system. The complex gravitational interactions between planets and dwarf planets like Pluto illustrate the delicate balance that exists in space, where even the smallest changes can have profound effects over time. Astrophysicists like Tyson continue to explore these mysteries, reminding us that the universe is far from static and that our understanding of it is ever-evolving. Looking ahead, it's clear that space exploration will remain a rich field of discovery, one filled with surprises, mysteries, and new revelations waiting to be uncovered.